Recall that in our study on motion and its causes, we talked about the study of motion and also the force that causes motion, where we define force as any agent that changes or tends to change the state of rest or of uniform motion of an object. Basically, we said we have two types of force: contact force and force field. Now let's talk about the concept of linear momentum. Momentum is an important property of a moving object because it explains its tendency to continue to move on a straight line. By definition, momentum is defined as the product of mass and its velocity. Mathematically, m is equals to mass times velocity. You discover that you have m for momentum and also m for mass. So in case of writing the symbols, momentum is written in capital letter, while the mass is written in small letter. The picture on the screen shown is a typical example of balls arranged on a straight line. The tendency of the balls to continue to move on a straight line has to do with momentum. Let's take a look at the concept of impulse. Impulse is a product of large force and a very short time in which they act. The unit of impulse is Newton seconds. Mathematically, impulse I equals to Ft, and it's also equal to change in momentum. Change in momentum is equals to mv minus mu. Now, change in momentum will be discussed proper under the conservation of linear momentum. In terms of impulse, m is the mass of the object, v the final velocity, and u is the initial velocity. Now let's take a look at examples under impulse and momentum. Example 1. A truck of mass 3,200 kilograms moving with a velocity of 10 meters per second increases its velocity to 20 meters per second in 5 seconds. Calculate the magnitude of the force exerted on the engine and the impulse of the truck. Let's take a look at the solution to this. As usual, our parameters, example 1, our parameters include our m, which is mass, is 3,200 kg. Our initial velocity is 10 meters per second. Our final velocity v is 20 meters per second. The time taken for this to occur is 5 seconds. Now we are asked to find F, which is the magnitude of the force, and at the same time find our impulse. Now, with this, we're going to use the first equation of motion. From the first equation of motion, recall that V equals to U plus AT. U plus AT as the first equation of motion. So from this, we are looking for acceleration. So we can make this guy, acceleration is subject to the formula. And by so doing, we can have V minus U equal to AT. That is when U crosses to the other side. Divide both sides by T. This and this will go. Our A becomes V minus U all over T. So we're going to use this formula to find the acceleration of the truck. And when that is done, we have our A is V minus U all over T. A equals to V minus U all over T. A equals to, now V is 20, U is 10. Like I said earlier, U is the initial velocity, while V is the final velocity, all over the time taken, which is 5. Therefore, A equals to 20 minus 10, this is 10, all over 5. So our A is equal to 10 divided by 5 will give us 2 meters per second squared. Now, having obtained the acceleration of the truck, we can now determine the magnitude of the truck. From Newton's second law, F is equal to ma. So we're going to use this formula to find the magnitude of the truck. Recall that we are given the mass to be m is 3,200 kilogram, and we just calculated A to be 2 meters per second squared. So therefore my F becomes 3,200 multiplied by 2. When you do that, when you multiply 3,200 by 2, you're going to have 6,400 newtons. So this is the magnitude of the force. That's the first question. The second question, we're asked to find the impulse. Our impulse I, from our definition of impulse, I is equal to Ft. That is, our I, which is impulse, is equals to force times time. Force is 6,400 multiplied by time, which is 5 seconds. And if you do that, you're going to have our impulse I to be equal to 32,000. And we say the unit of impulse is Newton seconds. That is because we multiply time by force. So basically, this is the solution to the first problem. You find the acceleration for equation of motion, and also find the magnitude of the force from the law of from Newton's law of motion. So basically, the knowledge of equation of motion cannot be overemphasized, because any question that has to do with motion finds application using equations of motion. Now let's take a look at another example. Example 2. A body of mass 2 kilograms moving vertically upward has its velocity increased from 10 meters per second to 40 meters per second in 4 seconds. Neglecting air resistance, calculate the upward vertical force acting on the body. You are given that your G, that is gravity, is 10 to the power of minus 2, that is 10 meters per second squared. Now let's take a look at the solution to this particular problem. So in example 2, we are given the following parameters. Mass is equals to 2 kg. Our u, which is the initial velocity, is 10 meters per second. Our v, which is the final velocity, is 40 meters per second. And this took place for 4 seconds. We asked to find the magnitude of the force. Now, this is similar to the first example we did, so we'll just go straight to the solution. Our F is equals to ma. That's force is equals to mass times acceleration. Mass times acceleration. Now we need to obtain the acceleration. And how do we do that? From the first law, in our first example, we resolved that A is equals to V minus U all over T. So when you put the values, you're going to have 40 minus 10 all over 4. So our A in this case is equals to 40 minus 10 will give us 30 all over 4. Now when you divide 30 by 4, you're going to have 7.5. So my acceleration now, A is equals to 7.5 meters per second squared. Always endeavor to add your units. Having obtained acceleration, therefore our F is equal to m times A. Our M is 2 kg multiplied by 7.5. When we multiply 7.5, our F will be given to be 15 newtons. So this is the magnitude of the force acting in the vertical plane.